Bismillahirrahmanirrahim. Our today's lecture is about number system conversions. Today we are going to discuss the conversion of non-decimal numbers to decimal numbers and decimal numbers to non-decimal numbers. So non-decimal numbers to decimal numbers conversion. To convert non-decimal numbers, multiply each digit by its weight and add. The sum is the desired decimal number. Decimal numbers to non-decimal numbers. To convert a decimal whole number to the desired base r, begin by dividing the whole number by r and then dividing each resulting quotient by r until the quotient is 0. The remainder form the number in the desired base. So this is a repeated whole numbers, whole decimal numbers. Decimal whole numbers are converted to non-decimal numbers by repeated division. To convert a decimal fraction to any base r, begin by multiplying the fraction by r and then multiplying each resulting fraction part of the product by r until the fraction product is 0 or until the desired number of decimal places is reached. So to convert decimal fraction, we use repeated multiplication. To convert decimal whole numbers, we use repeated division, and to convert decimal fraction, we use repeated multiplication. Non-decimal numbers to other non-decimal numbers. To convert non-decimal numbers to other non-decimal numbers, first convert non-decimal to decimal and then decimal, and convert the decimal to the desired base. So first convert to decimal and then convert the decimal to the desired base. For example, to convert base 3 numbers into base 5 numbers, so first convert base 3 into decimal and then convert decimal to base 5. For integral conversion of octal and hexadecimal number system, first convert it to binary and then convert binary to octal or hexadecimal. So this part of conversion, we will discuss this part of conversion in the next part of this lecture, in the second part of this lecture. Binary to decimal conversion. So this is a non-decimal to decimal conversion. So multiply each digit with its weight and add. The sum is the desired decimal number. So to convert a binary number to decimal, the decimal value of any binary number can be found by adding the weights of all bits that are 1 and discarding the weight of all bits that are 0. So when bit is 0, so there is no need to multiply 0 with its weight. So we only add the weights where there are 1s. So to convert this binary number into decimal, so the weight of this one is 2 raised to power 7, the weight of this one is 2 raised to power 6, the weight of this one is 2 raised to power 4, the weight of this one is 2 raised to power 3, and the weight of this is 2 raised to power 1. So to add these weights where there are 1, so 2 raised to power 7 plus 2 raised to power 6 plus 2 raised to power 4 plus 2 raised to power 3 plus 2 raised to power 1. 2 raised to power 7 is 128, 2 raised to power 6 is 64, 2 raised to power 4 is 16, 2 raised to power 3 is 8, and 2 raised to power 1 is 2. So this is equal to 218 in decimal. So this is the corresponding decimal number. Decimal fraction. To convert decimal binary convert the fraction binary number to decimal. So again multiply each digit with its weight and add. So there is no need for multiplying this 0 bit, so add weights where there are 1. So when we multiply 1 with weight, so the product is weight. So add weights only. Binary number is simple, so add weights where there are 1. So 2 raised to power minus 1 plus 2 raised to power minus 3, because the weight for this weight the bit is 1. and 2 raised to power minus 4 because the for this weight the bit is 1. So add these weights. So this is 0.5, 0.125 and 0. So the equivalent decimal fraction is 0.6875. So convert the binary number 10.11 to decimal. So again this is the binary number. So to convert it to decimal, multiply each digit with weight or add the weights where there are 1. So this is the equivalent decimal number 2.875. The sum is the desired decimal number. Hexadecimal, similarly we can convert hexadecimal to decimal by multiplying each digit with corresponding weight and add. So b, the weight of b, look, to convert this number the b to f8, this is an hexadecimal number. To convert this number to decimal, we multiply each digit with its weight and add. So this is the multiplication. Here b, we cannot multiply b directly with 16, so replace b by its decimal equivalent. So f is replaced by 15 and b is replaced by 11. So this product is 45056, this product is 5.12, and this product is 240, and this product is 8. So add these terms, so we get 45816 in decimal. So this is the equivalent decimal, this is the equivalent decimal number of the given hexadecimal number. So the same procedure, multiply each digit with its weight and add. The sum is the corresponding decimal number, the equivalent decimal number. Replace each hexadecimal characters. For multiplication, replace each hexadecimal character by its decimal equivalent. So b is replaced by its decimal equivalent 11 and f is replaced by its decimal equivalent 15. These are example of fraction, octal fraction. So again, multiply each digit with its weight and add. We replace hexadecimal characters by its decimal equivalent. So this is the corresponding number. So again, this is another example. So multiply each digit with add with multiply each digit with its weight and add. So this is replace the hexadecimal characters by its decimal equivalent. So a is replaced by 10 and b is replaced by 11. So solve these products and add. So 176 plus 2 plus 0 plus 0. So this is the corresponding decimal number. Octal-to-decimal conversion, again this is the same procedure, multiply each octal digit with its weight and add. The sum is the desired decimal number. So look, the 2 is the weight of digit 2 is 8 raised to power 3, so 2 is multiplied with 8 raised to power 3 plus 3 is multiplied with 8 raised to power 2 and 7 is multiplied with its weight 8 raised to power 1, and this 8 is multiplied with its weight 8 raised to power 0. So multiply and add. So 2 raised to power, this is the multiplication and addition. So 2 multiplied by 8 raised to power 3 is 5112, 8 raised to power 2 is 64, and 8 raised to power 1 is 8, and 8 raised to power 0 is 1. So this is the corresponding or the equivalent decimal number 1280 in best 10. So this is the octal number and this is the decimal, the corresponding decimal number. Decimal to the conversion of decimal to non-decimal numbers. So for whole decimal numbers, for decimal whole numbers, we use repeated division as we have discussed earlier, and for decimal fraction we use repeated multiplication. So to convert decimal to binary, for binary conversion, so if to convert a decimal whole number to binary, begin by dividing the whole number by 2. The r here the r is 2, so divide by 2, the decimal whole number, and then dividing each resulting quotient by 2 until the quotient is 0. The remainders form the binary number. So this is the same procedure we have discussed in the first slide. The first remainder is the LSB, least significant digit in the binary number, and the last remainder to be produced is the MSB, most significant bit. The second method to convert decimal to binary is sum of weight method. To convert a decimal number, express the decimal number as sum of binary weights and place a 1 in appropriate weight position. So this is the second method. One method is repeated division, and the second method is sum of weight method to convert decimal to binary. So this is a decimal whole number 37. So in this example we are going to convert 37 into binary. So we are going to convert this 37 decimal into binary. So divide this decimal by 2. So first step is divide the number by 2, so we get a quotient and a remainder. This is the first remainder, and the first remainder is the least significant bit. This is the rightmost bit. 18 divided by 2. This is the quotient, so you have to divide the quotient by 2. So in this division we get 9 as a quotient and 0 as a remainder. Again divide 9 by 2, so we get 4 as a quotient and 1 as a remainder. 4 is divided, this 4 is divided by this 4 is divided by 2 again here, so the quotient is 2 and the remainder is 0. 2 divided by 2, so the quotient is 1 and the remainder is 0. 1 divided by 2, so the quotient is 0. This is the stopping criteria. You have to stop here when the quotient is 0, and this is the last remainder. So the last remainder is the MSB and the first remainder is the LSB. So this is the last remainder, so this one represent this one in the binary number. This is MSB and this is LSB. This one represent this one. So 1, then this 0, this is this 0, this 0, this is this 0, 1, this is this one, 0, this 0, and 1, the last one, the first one, LSB. So this is the least significant bit and this is the most significant bit. This is another example to convert 45 decimal into binary. So repeatedly divide, this is a whole number, so repeatedly divide 45 by 2 and compute remainders. The remainders forms the binary number. So this is the last remainder, MSB, most significant bit, and this is the first remainder, LSB, least significant bit. So 45 and decimal is equal to 101101 binary. This one, this bit is MSB in binary and this bit is LSB. Converting decimal fraction to binary. So fractions are converted by repeated multiplication. Decimal fraction can be converted to binary by repeated multiplication by 2. To convert decimal fraction to binary, begin by multiplying the fraction by 2 and then multiplying each resulting fraction part of the product by 2 until the fraction product is 0 or until the desired number of the decimal places is reached. The carry digits are carries generated by multiplications produce the binary number. The first carry produced is the MSB and the last carry is the LSB, least significant bit and most significant bits. Example. So to convert decimal fraction 0.3125 to binary, so multiply this fraction by 2. This is the first multiplication, this is the product. So the whole part of this product is 0. This is the carry, and these carries are the whole part of these products will form our binary fraction. So when we multiply the first step, we will multiply the decimal fraction by 2. So we get this. This is the fraction part, and this is the whole part. The whole part is 0. So this represents the whole part of the carry. We have to multiply again the fraction part of the product. So 6.625 is the fraction part. So multiply 0.625 by 2 so we get 1.25. so again the fraction part is 0.25 and the whole part is 1, or the carry is 1. So this is the whole part, and we have to multiply 0.25, we have to multiply again by 2. So 25 in 0.25 is multiplied by 2, we get 0.50. so 0.50 is the fraction part and this 0 is the whole part. So this is the the carry, this is the carry. So again the fraction part is multiplied 0.50 multiplied by 2, 1.00. so the fraction part here, the fraction part is 0. So when this is the stopping criteria, when the fraction point fraction part is 0, or when the desired decimal number of decimal places is reached. So we have to stop here. These are the carry bits: 0, 0, 1, 0 and 1, and this is the order in which we have to combine these bits in a binary fraction. So this is the MSB, most significant bit, and this is the LSB, the least significant bit. So this is the equivalent decimal binary fraction of this decimal fraction. So decimal fraction are converted to binary or other systems by repeated multiplications, and this is the procedure of repeated multiplication. So this is another example: convert 0.125. So again multiply the decimal fraction by 2, so we get this is the carry. Again 25 is the fraction part, so we have to multiply again the fraction part. So 0.5, product is 0.5, the carry is 0. So 0.5 is multiplied by 2, so the carry is 1 and the fraction part is 0, so we have to stop here. So this is MSB 0, 1, 1, so 0, 0, 1. So this is LSB and this is MSB, and this is the equivalent binary fraction. Convert decimal number 12.3125 into binary. So convert a whole part, this is a whole part, split this number into whole part and fraction part. So convert whole part by repeated division, and convert fraction part by repeated multiplication that we have discussed in earlier examples. So this is the conversion of 12, and this is the conversion of 0.1 to 0.3125, and combine both the results, so we get the corresponding binary number. As we have sum of weight method, this is the second method to convert a whole number or a decimal fraction to binary. So in sum of weight method, we express the decimal number as a sum of binary weights. So for example, to convert 9 into binary, so express this 9 into sum of binary weights. So 8 is a binary weight, 1 is a binary weight, so 9 is equal to 8 plus 1. 8 can be this is the weight 2 raised to power 3 plus 2 raised to power 0. This is the weight of 1. 1 is 2 raised to power 0 and 8 is 2 raised to power 3. So these are the weight structure of binary numbers. So look, the highest weight is 2 raised to power 3. So 3, this power shows, this 3 shows that this is a 4-bit number. So place 1 for each weight present, and place 0 for absent weights. So the weights start from 0 up to 3. We have a weight of 2 raised to power 1 and weight of 2 raised to power 2. So 2 raised to power 1 is not present, 2 raised to power 2 is not present. That's why for those weights we place zeros, and weights which are present, for these weights we place 1. So 2 raised to power 3, this is a bit of 2 raised to power 3 weight, and this is this one is for 2 raised to power 0 weight. To convert 142, these are examples, and they are these are examples, and they are solved in similar manner. Let's take this 142. So 142 can be expressed as sum of weights 128 8 4 2. So 128 plus 8 plus 4 plus 2. So 128 is 2 to the power 7, 2 to the 8 is 2 to the power 3, 4 is 2 to the power 4, and 2 is 2 to the power 1. So place 1 for these weights and zeros for absent weights. Decimal to octal conversion. So decimal whole numbers are converted to octal by repeated division. So we have to divide the decimal whole number by 8 to convert it to the octal number. So let's take this example. 359. So to convert 359 into octal, this is a decimal number, so to convert it into octal we have to divide this repeatedly by 8. So the division procedure is the same as we have discussed in binary number system. The only difference is here we divide the decimal number by 8. So to convert a decimal whole number to an octal number, repeatedly divide the decimal number by 8 until the quotient is 0. So the remainders constitute the corresponding octal number. The first remainder is LSD, rightmost digit, and the last remainder is MST, the leftmost digit. So first multiplication produce 44 as a quotient. First division produce 44 as a quotient and 7 as a remainder. This is the first remainder and the least significant digit of the octal number. 44, this is the quotient, so we have to multiply 44 by 8 again. So the quotient is 5 and the remainder is 4. When we again the quotient is 5, so 5 divided by 8, so the quotient is 0. This is stopping criteria. We have to stop here. There is no need for further division. The remainder is 5, so this is MST. So 359 in decimals is equal to 547 in octal. To convert decimal fraction to octal, repeatedly multiply the decimal fraction by 8. To convert a decimal fraction to octal, begin by multiplying the fraction by 8 and then multiplying each resulting fraction part of the product by 8 until the fraction product is 0 or until the desired number of decimal places is reached. The carry digits are carry generated by the multiplication procedure. By multiplications produce the octal number. The first carry produced is MST and the last carry is the LST. So again this is the same procedure. So to convert the decimal to octal, so again it has two parts, the whole number part and fraction part. So whole part is converted by repeated division and the fraction part is converted by the repeated multiplication, and then at the end we combine both the result. So 0.125 multiplied by 8, so 1.00. So this is the fraction part is 0, this product, so this is stopping criteria. There is no need to further multiply the fraction part. This is the carry digit which will be a part of our octal number. So this is the repeated division to convert this 25 to octal. So the result is when we combine 3.1 octal to 0.1 octal and 0.1 octal, we get 31.1. So 25.125 is equal to 31.1 in octal. So this is the conversion. Decimal to hexadecimal number in decimal to hexadecimal conversion of decimal whole numbers are divided by 16 to convert them into hexadecimal, and decimal fractions are multiplied by the decimal fractions are multiplied by 16 to convert a decimal fraction to an octal fraction. So this is the example of decimal conversion of decimal whole number to hexadecimal. So this is the repeated division method. This look, the when we multiply when we divide 365 by 16, we get quotient, 22 as quotient and 13 as remainder. Keep in mind 13 this is a decimal number, so you have to replace this remainder by its hexadecimal equivalent. So the hexadecimal equivalent of this 13 is D. So this is the least significant digit. The first remainder is the least significant digit. 22 is divided again by 16, so the quotient is 1 and the remainder is 6. 1 divided by 16, the quotient is 0. This is stopping criteria, we have to stop here, and this is the last remainder. So 365 in decimal is equivalent to 16D in hexadecimal. To convert decimal fractions in hexadecimal, multiply the fraction by 16. The product, fraction part of the product is remultiplied by 16 until the fractional part is 0. So 12. So the carry is 12 here. So 12 we have to replace. This is a decimal 12. So 1 2. So we have to replace this by its hexadecimal equivalent. So the hexadecimal equivalent of decimal 12 is equal to C. So 0.75 equal to 0.C in hexadecimal. This is another example. So D, to convert 0.86 into hexadecimal. So multiply this decimal fraction by 16. So first product is 13.6. So 13 is the carry. So 13 is decimal. So we have to the decimal equivalent of 13 is the hexadecimal equivalent of 13 is D. 0.6, so 9.6, so 9, 0.6, 9. So if you continue, it will go 13, 9, 9, or D 9, 9, 9, 9. So this is what the conversion of 0.86 decimal is equivalent to 0.D999. Thank you very much.